Hi and welcome to Lecture 8 in the UX Design Prototyping course given by the Technical University of Denmark. We're going to look a little more into how can we create some smart healthcare apps. And one of the really great tools for this is the Apple Research Kit, which is now an open source framework. It's like lots of little Lego building blocks for doing medical tests. And what is really interesting, I think, is the way this has evolved from being something where you say, instead of making clinical tests at a hospital and people move in and out and they do the test and they go back, how could we encapsulate what you want to test instead in an app, distribute the app, and then rather than having hundreds, if you're lucky, participants, you could have tens of thousands of patients collecting data, and it would totally change the way you do research. That's why it's called Research Kit. But I think there's some other aspects which makes this really interesting, which is more like along the lines we talked about earlier in terms of design thinking. What is we actually want to attain, or in the words of Harvard Business School Professor Clayton Christensen, where the jobs to be done. What is it we want something to attain for us? And here I think there's some really nice examples here from Apple, which is let's say Parkinson's disease, where you would say in a medical test, you would want to assess how quickly do your fingers respond to your intent of doing this. And instead of going into the clinic, you could do this at home, and you can do this on your phone, just using the touchscreen. So that's really nice, right? But what I think is perhaps where it goes one step further than this, in more along the lines in design thinking, would be to say, okay, if you collect this data yourself, and I've seen some examples of this in the Quantified Self community, then patients suffering from Parkinson's disease can actually kind of adjust their medication based on this. Then they will say, okay, when my fingers feel like this, it means I should start taking my pills and not just at a prescribed hour. So you can see then we move from, it would be nice to have people not going into hospital, you could do this at home, to not only that, you can improve their quality of life. And that's where we want to go. Other examples of, let's say, reconceptualizing how do you test for something here would be an autism test for kids, where they watch a little video, and then the camera on the phone will watch them and see how do they react. And then you would collect the data from lots of kids and figure out, based on the facial gestures, is there some indication of where you are on an autism spectrum. There could be things like this app here, which is thinking how can we keep track of epileptic seizures for people suffering from this? How can we use the watch for also both let's say collecting data and maybe alerting all the people and so on. So really nice concepts. And you could say people who want to do something like in this case here, where somebody says maybe we could even figure out the emotional state of people just by utilizing the sensors on the phone, then you don't start from scratch. You use this Research Kit thing for accessing the sensors, putting the things together in an app, and it's really quick, rapid prototyping, but based on some very complex stuff. So we are moving a little beyond just making drawings now. This is things which have been drawn for us, but it's a lot of code which has gone into this. So if we take the example of hearing care, you could also here say, how can we encapsulate this in an app? What is it we would like to attain? Because normally the treatment stops with you having an audiogram, which means we test for the hearing loss. Then they give people the hearing device and maybe some small adjustments, but not really for people who feel like, I can make this work. It will take very many hours to adjust. And in some places in the world, there are simply no audiological resources at all, right? So if we could encapsulate this in an app, it would be great. So what we would encapsulate would be the normal process. The audiogram, figuring out some things with the gain, the actual amplification, This is where it stops. Then we would add the other things which we would really like to have, which is this personalization of settings. What are your preferences in terms of the timbre of the sound, directionality, noise reduction, and so on? And you would end up with a profile. And in this case, you could say our app should then be able to figure out what are your preferences along these audiological parameters, because these are the parameters we would use to then go in and actually change something on the device. And you would end up with settings like these. And as we talked about before, not just one, we could have 4 parallel settings which would move a little more towards the left or towards the right here, meaning more or less directionality, more or less noise reduction, and so on. The way you do this is you work in Xcode, and there you have all the little elements in, so you can see here in the left pane, lots of little code Lego building blocks for doing something like, in this case, the audiometry test, so you don't have to build the audiometry test yourself. What you do is, of course, you adapt the interface to what would you like it to do. And then it collects data the way that you listen to something on the headphones. When you can hear the sound, you press a button. And based on that, it will generate data like this, which says, okay, within these specific frequencies, when did you respond? What does this signify in terms of your hearing loss? So this would be a way to create the audiogram. But you could also say, why stop there? Why couldn't we do all these other things with the preferences? So you could imagine that you would add things like, after the audiogram, maybe we could personalize these settings. Maybe we could also look a little at more cognitive aspects like memory, because we know that working memory will go in and try and compensate for the hearing loss, which means that you will actually lose some of your working memory, because you will now be occupied with trying to make sense of sounds, which would normally, if they were probably amplified, you would be able to process in the auditory cortices. But there could be a sort of a more holistic approach to what is it you want to do. You create your own little app with these aspects here. So some of them would just be, we could start by saying, okay, if we want to have like a dialogue, what are the questions we ask? And those questions would be coupled with audio samples where you could hear what it sounds like, and you could switch back and forth. So here, as you can see, we try and reduce these more complex parameters to yes, no, A, B type of tests. And then maybe we could do something like this, where there's already in the toolbox ways where you could make puzzles, or you could make cognitive memory tests of various kinds, and you would say, thanks, now we collected your data, and we could work with that. But the other thing is to say, well, why would we stop there? Because the hearing aid does have microphones, which makes it look a lot more like the AirPods from Apple, where you can talk to Siri, as it says at the bottom. So you would talk to this voice bot, which would be able to actually understand what you're saying. And in this sense, we now move from an app to something which we would call more like a cognitive interface, something we can interface with, understanding what we intend. And one way of doing this, as we mentioned in the previous lecture, is also to say, okay, once we have the voice input translated into structured data, what do we want to do with that data? And in this case, Facebook Messenger's wit.ai, artificial intelligence framework here for setting up what are the intents, what should happen when somebody says this and that, how could you structure this? So you can see here they have some nice little examples of flowcharts where you say something, if yes, then if no there, and you could say instead of yes, no here, we could have A, B, or louder, or whatever in these hearing tests. And the results would be that you can create these little bot frameworks where the user says this, the bot infers that, and it would then change settings. So the whole idea in this thing would be to create something like this, which is like a message thread, which keeps track of all the interactions with the user. So this would be really thinking, okay, the device now knows its state, it knows what settings it's in, because those settings would be like what we had before. Then it will ask the user about these things, and based on all the user's actions, or let's say responses, they would then trigger actions on part of the bot. So saying, okay, maybe I should go in and change a little on this trigger here, or this lever here, and adjust the setting. And that's something we would really like you to do. So this means that you go in and say, okay, I will try and make this device self-fitting. We want this device to be able to adjust itself. To do that, we need to create an app. That app, as we don't have time to build that, we will build that on top of ResearchKit. So there we would have the dialogue frameworks, we would have the audiometry tests. Maybe if we wanted the cognitive tests also from memory, they would also be in there. Then once we have them, we say we also have something like SiriKit, which is, okay, how do you attach a messaging app to this voice interface so you can register that, and it will use its artificial intelligence just for understanding your interactions with the app. And then further down in the app, the logic, we would have a message flow, which would be something like the Wit.ai thing, where you would have, okay, we go through these dialogues, but now it's not you just saying yes or no to something as if it would be in the ResearchKit alone. Here now you have a dialogue where if people say something different, or you want something confirmed, because it's probably not so easy as just A and B. There might be a lot of sort of, could I hear that again, or maybe not. Now again, I think it was better before. These types of things, and we could have a voice interface which would be able to do this on the app, and then you could say you would start having now a foundation for something which would be not any longer limited to a hearing aid. Now we are talking about a cognitive interface which actually provides or augmented hearing in terms of maybe not just the amplification which you need in specific frequencies if you're suffering from a hearing loss, but we could imagine devices like this for everyone who would in some challenging situations want more focus, or could we get this noise here removed, or whatever, where you would have this sort of augmented hearing interface where you could talk to the device and it would keep this message thread all the time, knowing what have you ever said, what are the settings we've ever had as a basis for turning that into something which would be really an augmented hearing cognitive interface.